Welcome everyone to the new outline of this course. This video is part 1. So let's see the agenda of today's lecture. First of all, we will see what is class imbalance. Then we will see what are the issues or problems with class imbalance. Later, we will see the causes of class imbalance. In the last, we will see some class imbalance techniques. So let's see what does the term class imbalance means. The term imbalanced data describes datasets where the target class has an unequal distribution of observations. One class label has a lot of observations, but the other has relatively few observations. Class imbalance is a frequent issue in machine learning, particularly with classification problems. Imbalanced data can seriously hamper the accuracy of our model. Now, what challenge comes with class imbalance? Predictive modeling is challenged by imbalanced classification because the majority of machine learning methods for classification were built on the premise that there should be an equal number of samples in each class. As a result, models perform poorly in terms of prediction, particularly for the minority class. This is a problem because, in general, the minority class is more significant, and as a result, the issue is more susceptible to errors in classification for the minority class than the majority class. Let's see the example of fraud detection. Let's suppose there is a bank that is concerned about fraudulent transactions. But after checking their data, they realized that out of every 1,000 transactions, 15 of the transactions are fraud. So the number of fraud per 100 transactions is less than 1%, or we can say the fraudulent transactions are relatively rare. Now here, if you train a machine learning algorithm, your accuracy for the majority class, which is non-fraudulent or non-fraud, would be almost 100%. But for fraud transactions or minority class, your accuracy would be almost 0. So what are the issues with class imbalance? An imbalanced classification problem is one where there are not an equal number of examples in the training dataset for each class label. That is, when the distribution of classes is biased or skewed rather than unequal or nearly equal. The key issue with imbalanced dataset prediction, to put it simply, is how well we truly predict both the majority and the minority classes. So what are the approaches to deal with class imbalance? It's crucial to appropriately identify the minority classes in specialized situations like fraud detection or disease prediction. Therefore, the model should not be biased to identify only the majority class, but should also give the minority class similar weight or importance. In the next slides, I go over a few methods that can be used to solve this issue. There is no right or incorrect approach here. Instead, several strategies suit various issues. Now, you might be wondering that what are the causes for class imbalance? In an imbalanced classification predictive modeling challenge, there may be several reasons for the class distribution imbalance. The two primary categories of explanations for the imbalance that we would want to take into account are data sampling and domain-specific characteristics. It's likely that the manner the examples were gathered are sampled from the problem area, contributed to the imbalance in the examples across the classes. This may involve biases imposed and errors committed during the data collection process. So the first one is biased sampling. For instance, it's possible that samples were gathered from a limited period of time or geographic area, and the distribution of classes could be significantly different or even collected in a different manner. The second is measurement errors. It's possible that errors were made during gathering the observations. The incorrect class labels being applied to numerous samples could have been one form of problem. Alternatively, the imbalance may have been brought about the process or systems from which the instances were drawn by being damaged or impaired. Often in cases where the imbalance is caused by a sampling bias or measurement error, the imbalance can be corrected by improved sampling methods and or correcting the measurement error. This is because the training dataset is not a fair representation of the problem domain that is being addressed. Possible characteristics of the problem domain include the imbalance. For instance, one class may predominate over others simply by virtue of its existence. This could be as a result of the process taking longer, costing more, requiring more computing, or requiring additional resources. Therefore, increasing the class distribution by merely collecting more samples from the domain is frequently impossible or unsolvable. To learn the distinction between the classes, a model is needed. Now, what techniques for class imbalance do we have? There are different techniques for handling class imbalance, but in this course, we will only see some of the most common techniques, such as SMOT, which is also known as synthetic minority oversampling technique. The second is random oversampling. The third one is random undersampling. Now, good luck. See you next time.